Okay, today we'll start new chapters, linear programming, and introduction, first part of the business mathematics course. And this is the actually linear programming. Linear is a and programming. There are two types in this word, important word, linear. Actually, linear means we must know linear equations, and programming this is an actually arrangement of equations. There are two types of equations here. Actually, one is objective functions and other are constraints. And today we'll start about linear programming, and this is the first part. Actually, linear programming. What is LPP? LPP means what? Linear programming problem. Actually, what is LPP? This part. This is actually an optimization technique. Optimization technique means we have to maximize profit or minimize cost. This is actually in business and or in economics or in finance. We have to optimize the technique, because we have to maximize the profit or maximize the revenue and minimize the cost or minimize the any any types of cost, regarding cost. So this optimization in everywhere, actually we are using these optimization techniques. Suppose in our body to food, suppose we have to design a food problem for our necessary uh, uh, in our family. If you want to apply the food problem, because the intake of food, we need food, and we have to optimize the food, because in food there are great relation, there are different types of relation in taking food, because suppose we want to design a diabetic problem, but in this diabetic, you must know, we have to design the food, types of food. Okay, we have to optimize the food, maximize some foods and minimize some foods. So there are depending on cost. Actually, it depends on cost. You have to minimize the cost. Okay, and you have to minimize the sugar also in our blood to control the diabetes. So there is and it actually happening there, optimization problem here. Suppose you are involving in a business, you have to optimize the cost, you have to optimize the revenue, or you have to optimize the profit. That means maximize. Optimize means actually maximize or minimize, anyone, to find the optimal values of the objective function, that is maximum or minimum. That means maximum or minimum happening in everywhere. Suppose in our body there is a blood pressure. Okay, the lowest one is 80 uh, pressure, and highest is was 120 AZ pressure. Okay, so we have to optimize this pressure, and this pressure actually depends on what? Anxious, hard work, taking food, habit of food, and habit of lifestyle. There are different kinds of condition, and that means uh, this this disease, blood pressure, that means hypertension, depends on different kinds of conditions. Actually, these conditions is called constraints or condition. Okay, so linear means all mathematical functions are required to be linear. That means a straight line, or all will be what? Straight line. And linear means what? Straight line. Linear means all the mathematical functions are required to be linear. And programming refers to planning. You have to plan, you have to arrange these conditions in a programming way, not computer programming. This is actually not computer programming. And we will use actually graphical method for this linear, one of the linear programming method, and this is the actually linear programming. So and it is an optimization problem, and this linear programming has the linear word and programming word. Actually, linear word means what? Mathematical functions which are involved in linear equations, and programming means actually refers to planning, not actually computer programming. Understand? Now this linear programming and overview. Okay, then we have to model formulation and characteristic of linear programming we are studying, and assumptions of linear programming model, advantages and limitations of linear programming. Hmm. Okay, you must have Assam Shahidul Islam book, I hope everybody have, and you will get this. And the a maximization model example, we will practice it, maximization model example, and graphical solution of linear programming models. Okay, this is the main problem will solve in next lectures. A minimization model also with an example, and irregular types of linear programming models. Suppose objectives of a business decisions frequently involve maximizing profit or minimizing cost. I am saying actually about this, as you are business students and you have to maximize the profit or minimize the cost. So you have to use linear programming for in that case. And linear programming uses linear algebraic relationships to represent a firm's decision. Farms means what? It's maybe industry also. Okay, and given in business objectives and resources means what? Constraints means what? Actually conditions regarding to objectives. Okay, to fulfill the objectives, we have to design some constraints or conditions. Actually, this resource means what? Actually conditions. The steps in application, actually identify problem as solvable by linear programming, but you have to, first of all, you have to verify whether it is solvable in linear programming. And we have to formulate a mathematical model of the unstructured problem. Okay, suppose we are given some conditions and we have to make it a problem, like look like linear programming problem. So you have to formulate it, formulate this model from the unstructured problem. Solve the, then we need to solve this problem. Then we have to implement this result, whether it is acceptable or not. We have to make a decision, and this is called actually decision making. Okay, now there are different types of parameters and variables are required for this linear programming model. And decision variables, actually mathematical symbols represented labels of an activity of a farm or any industry or any business business purpose or any kind of model, to make a model. Okay, an objective function which will be a linear mathematical relationship describing an objective of the farm in terms of decision variable. This decision is to be maximized or minimized. We have to maximize the profit or minimize the cost or maximize the revenue. Okay, and this is called actually what? Objective function. Which function you have to maximize or minimize. And now constraints means what? Limitations or conditions. Okay, these constraints means what? Limitations or conditions, requirements or restrictions, okay, placed on the farm or any industry or any model by the operating environment stated in linear relationships of the decision variables. And all the variables will be x or y, z, etc. But this relationship will be straight line. Remember it. This is why linear relationship. This will be linear, not non-linear. Okay, now we may use to parameters, actually numerical coefficients or constants you must number. Okay, any number without variables is called constants, used in the objective function and constants. We can use these parameters actually. So characteristics of linear programming problem, actually what is the characteristics of linear programming problem? A decision amongst the alternative courses of action is required. A decision amongst the alternative courses of action. Actually there are different kinds of action. You have to amongst all the alternative actions, we have to take some samples of the decision. Okay, the decision is represented in the model by decision variable. Decision variable means only variable x, y, z, etc. variables. The problems encompasses a goal expressed as an objective function. Okay, the problem, there will be an objective function that decision maker wants to achieve. We have to achieve a decision. That means we have to optimize the model with this objective function. Uh, this may be maximize the profit or minimize the cost. And restrictions means or limitations represented by constraints exist that limit and extent of achievement of the objective. Actually, these restrictions or limitations are used to only the achievement of this objective function. Okay, the objective and constraints must be defined by linear mathematical relation, functional relationship. That means a straight line. Okay, straight line. You must know the equation of standard form of equation of straight line. Some assumptions of linear programming model. Um, Suppose proportionality, and additivity, divisibility, and certainty. Okay, there are four types of uh, assumptions of linear programming model. First of all, proportionality. Actually, what is this we are studying? The rate of change of the objective function and constant function is constant. Okay, the rate of change of objective function, the objective function will be y equal to f of x. Suppose this is the objective function. If we take the rate of change of objective function and the constant equation is constant, this will be no, there will be no change. Okay, that means this rate will be equal. Additivity, terms in the objective function and constants equation must be additive. Okay, additive law will be exist. And divisibility also, decision variable can take on any fractional value. Fractional value means point, fractional value 0.06, 0.73, etc. A fractional value, and are therefore continuous as opposed to integer in nature. Okay, integer number. Certainty, values of all the model parameters are assumed to be known with certainty. That means non probabilistic. Actually, this all the decision variables will give this certain decisions. Okay, not non probabilistics. Now, advantage of linear programming, why you are using actually this programming, linear programming, in different kinds of problem model, especially in business model and disease model, and in farm model or in an industry model, etc. Why you are using this? Actually, it helps decisions maker to use their productive resource effectively. That means the productive resource will be very very effective when we will use this linear programming model, and you can take a decision using this productive resource effectively. So another advantage is the decision making approach of the users become more objective and less subjective. That means if after applying this linear programming problem, we can approach a decision. That means whether we can maximize the profit or minimize the cost. So this is actually the user become more objective. That means he is very determined to get a good perfect result. Okay, in a production process, bottlenecks may occur. Okay, for example, in a factory, some machines may be in great demand while others may be lie idle for some time. Okay? For example, in factory, some machines may be in great demand while others may lie in idle for some time. A significant advantage of linear programming is highlighting of such bottlenecks. That means in industry, all machines are not working. That means some machines working and other is uh, being idle. Okay, other lying in idle. So if you use a linear programming model, then you can take a whole decision just using all the alternatives uh, and highlighting this. Okay, now there are also some limitations of linear programming model. uh, Limitations, you have to find out the this in limitations. Linear programming is applicable only to problem where the constants and objective functions are linear. Okay, and where they can be expressed as equation which represents a straight line. Without a straight line, you cannot apply this. Then you have to take another model. Okay, non-linear programming problem will be occurs then if this function, objective function or constants or both are not linear, then it will become non-linear. Okay, non-linear programming model. So if but we are studying about linear programming problems, so constants or objective functions or both will be must be linear. where they can be expressed as equation which represents straight line. In real life situation, when constants or objective functions are not or both not linear, this technique cannot be used. Understand it? I hope. Factors such as uncertainty, that means probabilistic, okay, and time are not taken into consideration. Time will be not take consideration. This is why this is the one of the limitation of linear programming. Now parameters in the models are assumed to be constants, but in real life situation they are not constant. But parameters in the model are assumed to be what? Constant, but in real life it is not actually constant, changeable. Linear programming deals with only one single objectives. Remember it. Linear programming deals with only single objective, where is in real life situation actually there are multiple and conflicting objectives. There are, that means not single objectives, more objectives are required in our real life situation. So this is one of the limitations. Then when more than one objectives are required, then it will be multi objective programming becomes, and it will becomes actually multi objective programming problem. Now another one is in solving a linear programming problem. LPP means what? Linear programming problem. In solving a LPP, there is no guarantee that we get an integer value. In some cases of no of man or machine, or non-integer value is meaningless. Actually, in machine, how many machines are working? Actually, not fraction. We cannot make use 2.5 machines. We cannot use here. Actually, how many product? How much product, number of units, okay, number of quantity, when you are taking number of quantity can never be fractional value. So in solving a linear programming problem, there is no guarantee actually that we get an integer value. Integer value means what? Actually whole numbers. It may be positive or zero actually. This is the actual limitations of linear programming problem. Okay, actually, what is linear programming? We are studying now. We have learned about many example, from many example. Say you own a 50 square acre farm. Suppose you have a 500 square acre farm. On this farm, you can grow wheat, barley, corn, or some combination of three. Okay, you can you can farm actually three types of corn: wheat, barley, and corn, or some other combination of the three. You have a limited supply of fertilizer and pesticide, but limited fertilizer and pesticide, both of which are needed in different quantities. Okay, for each crop grown, let's say wheat sells at 7 taka a bushel, barley is 3 taka, and corn is 3.50 taka. So how many of each crop should you grow to maximize your profit? Actually, there is a problem. This is a problem of maximizing profit, and in these types of profit there are limitation actually. How many crops here? Actually wheat, barley, and corn, combination of three. And this depends on a condition. What the condition? Actually fertilizer and pesticides. Understand? To if you use more fertilizer, and if you use more pesticides, then your production will be maximized. Understand? If less fertilizer and less pesticides, your growing crops will be minimized, profit will be minimized, and this actually the selling price. Okay, so how many each of crop should you grow to maximize your profit? This is this problem actually you have to take the help from linear programming problem. Actually, a mathematical tool for maximizing and minimizing a quantity, usually profit or cost. That means maximize the profit or minimize the cost, and subject to certain constraints, subject to some limitations. Limitations was actually some conditions applied in here. Of all the computation, and decision made by management in business, 50 to 90% of those involve linear programming. Remember it, very important topics today. Linear programming problem. So this in business area, actually 50 to 90% of those problem are linear programming. Now background on linear programming. Actually linear as a field of mathematics, linear programming is still a small child in math years. Okay, developed by Leonard Cantor around the time of World War II. Actually in 1945. In 1945, World War II happened, and U.S. Navy, U.S. Force actually applied this linear programming, and they have taken their decision in war to own from the enemies. Actually, they have applied a linear programming problem, and they are very successful in this problem, in this decision problem. They have taken more decision by involving linear programming. This is why this with the success of this linear programming in the World War II, the development of linear programming actually this is the root of linear programming problem, and background is what? World War II. Remember it. Further developed our following decades. Actually from that uh, poor development happened in linear programming. Today easily the most commonly used field for optimization. Actually this optimization technique is very useful in business, in economics, in engineering application, in different area we are using. We have to optimize, you have to use these optimization techniques in every hire. Actually suppose you have a budget in your family. Suppose you have a budget in your family. You have to optimize the cost of a family cost. Okay, you have to make a budget for that to maximize the to maximize the what? Maximize the happiness, to maximize the happiness in your family. Actually less food will not happiness. Okay, you have to increase the food supply, you have to increase the nutrition for your family, you have to increase the beautifying your family with the decoration. So there are different kinds of cost involved, and we have to optimize the cost. Optimize the cost means what? Minimize the cost but maximize the what? Happiness in your life. So there is actually commonly used optimization. Economics, business management, transportation, technology, planning, production, etc. Okay, this is the list goes on. So this is the actually maximum linear programming problem. Actually this is a design of a problem. This is the actually a maximum 8x1 plus 5x2 weekly profit, and this is the actually a problem. Mm, okay, the current production plan. Suppose the Galaxy Industries production problem, a company, the phototype example, the current production plan calls for producing as much as possible of the more profitable product, space re 8 dollar profit per dozen. Okay, per dozen what? 8. And use resources left over the produces jeepers a $5 profit per dozen. Okay, while the remaining within the marketing guidelines. The current production plan consists of space race 450 dozen, zappers 100 dozen, and profit what? Total 4100 per week. Understand? Total profit what? Actually per dozen 8. $8, 8 multiply 450 plus 5 multiply 100. Okay, 5 multiply 100 dozen zappers. Well, uh, per profit per dozen profit what? 5. This is why 5 multiply 100. This is why total profit what? 4100 per week. Now management is seeking a production schedule that will increase the company's profit. You have to you have to maximize the actually profit. That means increase the profit. Okay. Now, a linear programming model can provide an insight and an intelligent solution to this problem. Okay. And decision variables, which one actually we are taking decision. There are two decision variable, one x1 and another is x2. Understand? Weekly production level of space race in dozens. This x1 will be what? Weekly production of level space, and weekly production of level japers in dozen. Okay, x2. So x1 will be space and x2 will be what? Japers. Now objective function. Now objective function will be what? Weekly profit to be maximized. Weekly profit to be what? Maximized. So now x1 is the actually per dozen at $8. Okay, space what? $8. This is why total what? Total cost 8x1 and 5x2, 5 per dozen, and x2 is the japers cost per dozen. This is why total cost what will be? 5x2. This is the actually weekly profit, right? 8x1 plus 5x2. Now subject to the condition plastic, for plastic 2x1 plus 1x2 less equal to 1000, and 3x1 plus 4x2 less equal to 2400 production time, and x1 plus x2 less equal to 700 total production, and x1 minus x2 mix 350, where all xi will be non-zero. That means greater equal to 0, and therefore 1 and 2, because there are only two decision variable. Understand? Actually this is the linear programming problem. And first maximum 8x1 plus 5x2, this is called actually what? Objective function. Write down everybody. This is called what? Objective function. The function we have to which we have to maximize or minimize. This function is called actually what? This function actually what? Objective function. Remember it. Maximize or minimize. This is the actually will give the cost. Okay. Now this is the limitations. Actually this is the actually conditions. Okay, this whole, how many conditions here? 1 2 3 4. There are 4 conditions, and these 4 conditions is called limitations or constraints. Remember it. These 4 what? Constraints. CONSTRAINTS, constraints. And this is the actually non-negativity restriction, because number of product or number of quantity can never be negative. Remember it. This is why these decision variables can never be negative. So this x, that means x1 and x2. Okay, z equals to 1 2 means what? X1 or x2. This is called non-negativity restriction. Remember it. So in a standard linear programming problem, there are three types of there are three parts. One is objective function, another is constraints, and third one, which one? This is the non-negativity restrictions. Remember it. Solve how to solve graphically in linear programming problem. Now the procedure of our graphical solution. A graphical solution procedure linear programming with decision two variables can be solved or being in this way. Actually our previous example was for what? Two decision variables. Okay. Now we have to, first of all, we have to plot each constraints as an unique equation and decide which side of the lines is feasible. Okay, find the feasible region. Then number 3, we have to find out the co coordinate of the corner points of the feasible region. Then 4, substitute the corner point coordinates in the objective function. Then choose the optimal solution. That means we have to, there are 5 steps in solving graphical solution. Suppose there is another minimization problem, linear programming problem model. Minimize z equals to what? 5x1 plus twice x2. This is the actual objective function, right? This is what? Objective function. Subject to the constraints. Constraints means what? Twice x1 plus 5x2 greater or equal to 10, 4x1 minus x2 greater or equal to 12, and x1 plus x2 greater or equal to 4. This is the minimum problem. This is why the inequality is greater than. Remember it. for minimization problem, this will be what? Greater than, at least. Okay. And this is the non-negative restriction, because x1 and x2 will be greater or equal to must be 0. That means non-negative. This is called non-negativity restriction, and these three conditions is called constraints. Okay. And this is called what? Objective function. These whole three parts make linear programming problem. Understand, everybody? Understand? Now, graphical solution, how to find the graphical solution for this. uh, for constraints 1, if we take x1 equals to 0, we get x2 equal to 2. When x2 equal to 0, then we get x1 equals to 5. So we have to connect 5 0 and 0 2 from this. Suppose from the constraints, if we put x2 equal to 0, x1 equals to what? If we take x2 equal to 0, x1 equal to what will be? 5. Okay. And if we take x1 equals to 0, then x2 equal to what will be? Only 2. Okay. So if x1 equals to 0 in first constants, x2 will be 2, and x2, if x2 equal to 0, then we get x1 equals to 5. So there are 2 points of coordinate. One is 5 0, other is 0 2. Okay. Now from another constants, from second constants, if x2 equal to 0, x1 equal to what? 4x1 equals to 12. So x1 equals to only 3. If x1 equals to 0, x2 equal to what will be? Minus 12. Okay, minus 12, which is not on the graph. Thus we get a second point on the line x1 equals to any number of larger than 3. Therefore x1 equals to 5 and x2 equal to 8. So we have to connect 3 0 and 5 8 for greater equal to. From constant 3, if x1 equals to 0, we get x2 equal to 4. Okay, from 3, if x2 equal to 0, x1 equal to what? 4. And if x2 equal to 0, x1 equal to what will be? Only 4. So from third constant, we can take these 2 points, 4 comma 0 and 0 comma 4. X equals to 4, x1. First one is x1 and second one is x2. X2 means y. Okay, number of y. So we can plot this. This is the actually first constants. What? This one. Okay, this one is the first constants, right? 2 twice x1 plus 5x2 greater or equal to 10. Okay, there are 2 points. 2 points what? 5 0 and 0 2. Okay, 5 0, 5 0 is the this point, 5 0, and 0 2 is the what? 0 2 is the point. X equal to 0 and y equals to what? 2. And 5 0 means what? X equals to 5. 1 2 3 4 5. And y equal to 0 means what? Here. And connecting these 2 points. Okay, now for another constants, 4x1 minus x2, this is the actually, okay, this is the connecting point. And for this x1 equals, if we take x2 equal to 4 and x1 equals to 4 0, then we get this straight line. This is 4 0 and this is the what? 0 4. Now actually feasible region, which one? This is the actually feasible region, this red area. This red area is the feasible region. So there are 3 corner points. One is this 5 0 point, and this is the intersection point of what? Intersection point of equation constant 1 and intersection point of constant 1 and 3. Okay, 1 and 3. uh, and this is the another constraints, another intersection point of what? Point of 2 number 2 constraints and 3 constraints. Okay, just solving we get these 3, and this area will give the feasible regions. Actually we got 3 points. Understand, everybody? Now solve the stream the point intersection of the second and third constraints. Just solving. Okay, 4x1 minus x2 equal to 12, and x1 plus x2 equals to what was? 4. Now adding these two equation gives, actually if we take add, x1 equals to what? 16 by 5, and putting x1 equals to here in second equation, x2 equal to what will be? 4 by 5. Now solve another extreme point. This is the actually intersection point of what? constant 2 and 3. Okay, constant 2 and 3. Constant 2 and 3, what was constant 2 and 3? This is the three. This is the three number constants, and two number constants. Which one? This one. Two number constants, this and this three. Okay, this is the intersection point, 16 by 5 and 4 by 5. Understand? Just solving these two constants, second constant and third constants. Now again solve the extreme point for the to solving these two, we get another corner point. This is the third constant and first constant. Okay, just solving and multiplying the second equation by 2 minus 2. Okay, then the adding, we get x2 equals to 2 by 3. Then substituting this in any one, we get x1 equals to what? 10 by 3. So the point will be intersection point of first constant and third constant. What is 10 by 3 comma 2 by 3. 10 by 3 comma 2 by 3. This intersection point of what? Second constant and first constant. Third constant and first constants. Okay, just solving, we get the point which one? 16.5 and 4 by 5. Another point, this point, this point. There are 3 corner point. Okay, 3 corner point. One is 50 and other is intersection point of these two. These two money two means which one? First constants and third constants. Okay, and second point, top point, which one? Top point is actually third and second constants. Okay, third and second constants. We have solved this. Third constants and second constants and third constants will give this point, this point. Okay, and first constants and third constants will give the second point, and 50 is given. Okay, and if you put x1 equals to 16 by 5 and x2 equal to 4 by 5 in objective function, objective function what was this? 5x1 plus twice x2. Okay, x1 equals to what will be? 16 by 5 and x2 equal to 4 by 5. Okay, just calculating, we get z equals to what? 88 by 5. And putting x1 equals to 10 by 3 and x2 equal to 2 by 3 in objective function, we get z equals to what? 18. Just calculating. If we take x1 equals to 5 and x2 equal to 0, then z equals to what will be? 25. So actually this is the what types of equation? Minimization problem. So minimum z where? In which point actually? Minimum is this the 18. Okay, minimum is what? 18, right? Or 88 by 5, which one? Tell me please, which one is minimum z? Minimum z, which one? Can you tell me? 18 or 88 by 5, which one actually? 88 by 5 means what? Actually 88 by 5 is the minimum. So our minimum solution is what? Maximum minimum z equals to 88 by 5, and the decision variables x1 equals to what? 16 by 5 and x2 equal to 4 by 5. So the minimum minimization of this problem, minimum values of this problem occurs at what? X1 equals to 16 by 5 and x2 equal to 4 by 5. This is the actually solution of the linear programming problem.